in this lecture, we will talk about sum of geometric sequences. Now, if there are n terms, how are we going to add those terms together? We know this is a geometric sequence. We are given this one is a geometric sequence. Now then, by definition, sigma I ranges from 1 to n means here is ai. Then I choose 1 to n. So I is 1. Is the first one. I can choose 2 until the ending subindex. Sigma means the sum. Later on, maybe in calculus, you will see pi. That means the product. Right now, sigma means sum of all those n terms. And S sub n means the n terms add together. S means the sum. Yeah. Now, we know geometric sequence is that for this one, A2 is A1 times R. Okay. A3 is A1 squared. Okay. A4 is A1 cubed. And An minus 1 is A1 to the, you see down here. Remember, A2 and here is 1, then here is 1. Here is 1, here is 2, you got 3. So if here is 1, here has to be n minus 1, n minus 2, okay? And then right here is a 1 r n minus 1, because subindex add the exponent together is n. So that's what we got here. You see, yeah, that's what we get it. A2, that's A2, A3, A4, A sub n minus 1, An. Okay, so those two all are the same. Okay, now doing this way. All right, so down here, Sn is this one. Now I like to do is I want to use R2 times every term right here, every term right here. I use R times every term. So R times S sub n, then you will have a Rsn. Okay? And R times A1, I don't want to put here, I put here. Okay? Yeah. So A1 R. R times A1 R. So there you have a A1 R squared. So I want to put here. Okay? And R times A1 R squared. So you have a A1 R cubed. Okay? So like this. And similarly, this one, A1 R cubed times R, the blue R, you get A1 R to the 4th. Okay. And then down here, you see, it goes like that. A1 times A1 times R n minus 2, you have R on that, so you then have a this one comes from this one comes to here then, comes to here. Yeah. So let me do is right here. Okay, because r times r to the n minus 2 goes there. Yeah. And a1. This one comes from the previous one. Okay? Yeah. And then here is a1 r to the n minus 1, and then you times r, so you have a1 r to the n, because you know here the exponent is 1. You add 1 to n minus 1, then you know exponent is n. Alright? Now, up to this far, I want to use is this upstate one minus the downstate one. Okay. You see, if you use subtraction minus this one, so it was r s sub n, now you put negative in front of it. Negative in front of it, because you do a subtraction. Do subtraction. You know, here the starting term is a1 r. Here is positive a1 r. Here then is negative a1 r. And then here you have a1. Here a1. Here is r to the n minus 1. R to the n minus 1. Here there is an extra one. Is minus a1 r to the n. If you do the subtraction, all those terms in the middle, they cancel each other. That's the tricky part. Okay? So all the terms left over is what? Is a1 minus a1 times r to the n. Okay? So the right hand side, you only have a first term from the first expression, and the last term have a minus in front of it. Okay? From the second expression. That's right hand side. Left hand side, you have a s sub n minus r times s sub n. So you can pull s sub n out. Okay? There is a 1 in front of s sub n. Then when you pull s sub n out, so you have a 1 minus r. Okay? Because 1 is left. S sub n is out. So left hand side is 1 minus r times s sub n. Now both sides divided by 1 minus r. Okay? Right here, again, you can also pull a sub 1 out. Okay? Then you have 1 minus r to the n. Okay? And then both sides divided by 1 minus r. You then have a 1 minus r cancel each other. You have h sub n, that's on the left, equals a1 times 1 minus r to the n divided by 1 minus r without to the n. You may say the exponent is 1, but you know, you don't need to write that. That's the general formula for the sum of geometric sequence. Okay? You can see, very smart. H sub n is what? Is only you consider the first term, a1, and then the rest of them are the ratio operations about r. Okay? 1 minus r to the n divided by 1 minus r. This is the formula. Okay? We'll use this formula next time. Remember, we'll start from here. I'll see you next time.